Next we'll work example 6.14, which deals with root mean square velocity. So we have the equation where we can calculate the root mean square velocity of a gas as the square root of 3RT over the molar mass. And the molar mass of the gas has to be given in kilograms per mole, so that's the difference here. All right, and we're going to be using R in energy units. And the R in energy units, it's the same number, but it's just been converted to different units, is 8.314 joules per mole Kelvin. And 1 joule is 1 kilogram meter square per second square. Now, we have to convert our temperature to Kelvin, so our units will be consistent. And we need to convert our molar mass to kilograms per mole. So let's read the problem. Calculate the root mean square velocity of oxygen molecules at 25 degrees C. So our temperature is equal to 25 plus 273, which is 298 Kelvin. And the molar mass of O2, so each oxygen is 16 times 2 is 32 grams per mole. And we know that 1 kilogram is 1,000 grams, so we can convert to kilograms per mole. Now the root mean square velocity is just the square root of 3RT over the molar mass in kilograms per mole, so that gives us 3 times R in energy units, that's 8.314 joules per mole Kelvin, times 298 Kelvin divided by 32 times 10 to the minus third kilograms per mole for O2. That gives us the square root of 2.32 times 10 to the fifth joules per kilogram. And we know that joules are 1 kilogram meter square per second square. So if we plug that in for joules, we get the square root of 2.32 times 10 to the fifth kilogram meter square per second square per kilogram. So kilograms cancels and we're left with meter square per second square. When we take the square root of that, we get 4.82 meters per second. Now let's work the 4 practice problem. Calculate the root mean square velocity of gaseous xenon atoms at 25 degrees C. So the molar mass, let's change to a different color. The molar mass of xenon is equal to 131.293 grams per mole. Let's go ahead and convert that to kilograms per mole. 1 kilogram is 1,000 grams, okay? And that gives us, so grams cancels, and that gives us 0.131293 kilograms per mole, okay? So the root mean square velocity, that's nu RMS, is equal to the square root of 3RT over the molar mass in kilograms per mole, and that gives us the square root of 3 times R in energy units, 8.314 joules per mole Kelvin times 298 Kelvin divided by 0.131293 kilograms per mole. Okay. Now, if we convert that to energy units, we get the square root of, I don't know if you can see that. Let me move down a little bit. All right, so our mu, RMS, for xenon is equal to the square root of, so 5.66117 times 10 to the fourth. All right, and so we're going to convert our units from joules to kilogram meter square per second square. All right, and that is, let me back up a little bit. Let me rewrite everything in our previous units and the calculation, okay? So we've got the square root of 3 times 8.314 joules per mole Kelvin times 298 Kelvin divided by 0.131293 kilograms per mole. Okay? And we know a joule is, let me go ahead and erase this. A joule is a kilogram meter square per second square. Okay? So now let's cancel our units. So Kelvin cancels, moles cancels, kilograms cancels, and we're left with meter square per second square. So that gives us the square root of 5.66117 times 10 to the fourth meter square per second square. And that gives us a mu RMS of 238 meters per second for xenon at this temperature.